All right, folks, welcome back. We're in part 4 now, chapter 12, non-renewable energy resources. And in this part, we're going to talk about the limitation of fossil fuels. They're finite. We don't have an unlimited amount. And so as part of that, we're going to talk about something called the Hubbard curve, and we'll also talk about the future of fossil fuel use. And your objective for this section is that you'll be able to describe the projections of future supplies of our conventional energy resources. So if we take a look at this first graph here, this shows us that it shows us our year and then the value relative to 1950. And first thing that we're going to look at is per capita energy use. So as we can see, for the past 30 years or so, we've had a relatively stable per capita energy usage. So again, that's per person our energy usage value now versus in 1950. So obviously we are using more electricity, more energy. Think of all the electronic devices that you have versus, say, electronic devices that your parents or even your grandparents had. So per capita energy use is staying relatively constant, although our United States population and world population continues to increase. So we're using more and more energy, but the per person or per capita energy use has stayed roughly the same. The other thing to note is our energy use per dollar of GDP, which is our gross domestic product. That's known as energy intensity there, and that's been steadily decreasing. So what that means is we're using energy more efficiently to do what we need to do. But again, because there's more people, our population's increasing, and we're doing more things with the energy, our overall energy use has increased. This is the Hubbard curve, and it was developed by a guy named M. King Hubbard in the late 1960s, early 1970s. And it's the projected point at which the oil production is going to reach a maximum, and at the point that we're going to run out of oil. Okay, and so we've got two different versions of it here. We've got lower estimates and upper estimates of the reserve. And it shows the peak oil, and so he basically predicted that oil extraction and use would steadily increase until roughly half the supply has been used up, and that would be the peak oil point. And then at that point, extraction would begin to decline. Some people believe we've already hit the peak oil point. Others believe that we'll reach it very soon. Back in 1969, Hubbard predicted that 80% of the world's total oil supply would be used up in roughly 60 years. Now, since that time, we have discovered new petroleum reserves, and we always could potentially be finding more. But this theory, the principle remains the same regardless of how much petroleum we actually do find. For the future, we're looking at if current global patterns and our current use, our rate, if that stays the same and we don't find any more petroleum, we've got enough for less than 40 years. So again, that's within our lifetime. We're going to have a significant issue on our hands here. Coal, though, I think I mentioned in the last part, we've got at least 200 years, probably longer, for coal. So we've got a little bit more time with coal. But maybe we shouldn't be even thinking about that. Maybe instead we should, instead of thinking when are we going to run out of oil, maybe we should think about how can we right now transition away from fossil fuels before they cause even further problems. And before we even run out, let's figure out an alternative solution. Okay, we've talked about global climate change and CO2, and as of recently, gas prices have been relatively high in the past few years. They've fluctuated, but at one point in the very not so distant past, we were looking at gas prices of over $4 a gallon. And so these prices are really going to cause people to start thinking, okay, well, what else is out there? What other fuels are available? So again, we're going to be thinking about all of these things moving forward. We're going to be looking at renewable energy, which we'll talk about in Chapter 13, and there is the possibility of relooking at nuclear power, which we'll discuss in the next part 5. But for right now, we've reached the end. Really short one today. We've got our 3 checkpoint questions here. Explain the relationship between energy intensity and energy use per capita. Describe the Hubbert curve and its significance. And what are the major considerations involved in the future of fossil fuels? So take a moment, read through this section, and get your notes down, and get your ideas together before you open up Edmodo and answer these checkpoints. This is it for part 4, and then once you're done here, you can move on to part 5, which is the last part in chapter 12. Part 5 is all about nuclear energy.